What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandett.
Welcome to another episode of the Concrete Logic Podcast, and today I have Colin Lobo with me. He is the Executive Vice President and Division Head of Engineering at National Ready Mixed Concrete Association, NRMCA. Dr. Lobo, he oversees the Research and Engineering Department at NRMCA, and he leads initiatives to improve concrete quality, sustainability, and performance. His work includes developing technical guidelines, conducting research, and representing the industry in various codes and standards. And he's a concrete educator as well. So that's why he's here today. And we're going to talk about prescriptive specifications versus performance specifications, which is a topic that has, come about again recently with our changes in our material. But before we get started, just want to remind everybody how you can support Concrete Logic. There's several ways you can do that. The first way is if you enjoyed the episode today and you learned something from it, please share this with a colleague or a coworker. We're on every platform, so there's no excuse for folks not to listen to us. So if you hear something that was intriguing or you learned something, don't be selfish and share it. The next way you can support the show is if you go to concretelogicpodcast.com. There are a couple ways of getting a hold of me. There's a contact button in the upper right-hand corner. Click on that. It's like sending me an email. Or in the bottom right-hand corner, you could click on the microphone, and that will record a voicemail. It'll send me a voicemail. So what we're looking for there are topic or guest suggestions. Colin was a suggestion from a listener. So that's how it works. You tell me what you want to hear, what topics you want to hear, or who you want to hear from, and I will chase them down. The next way you can support the show is there's a donation button on the homepage of concretelogicpodcast.com. So if you feel like there's a dollar amount that the episode is worth to you, you click on there and you give any amount, which is fantastic. Any amount is appreciated. Or you can join us at concretelogicacademy.com. That's a new spot that we've started that you can join other folks that are passionate about concrete, where we're sharing ideas or discussing things maybe that we don't want to discuss out in public. We could discuss it amongst ourselves. You can join that as well. So check that out, concretelogicacademy.com. Colin, I think a good spot to start today is if you could define for us what a prescriptive specification is and what a performance specification is.
Very good, Seth. Thanks for having me. I appreciate the invitation and the opportunity to talk a little bit about specifications. So, concrete is probably, as everybody says, the largest construction material used in the world. It is sort of like baking a cake, where you use the flour as cement and the nuts and fruit cakes as the aggregates, and put a little bit of water, mix it all up, and you get a product that can be customized to a wide range of tastes, strengths, um, durability, etc. So it's a pretty interesting material. So traditionally, we have been essentially targeted to develop concrete mixtures by a purchaser or a designer telling us how to put that cake together. Okay. So they tell us that we need to use so much cement. We can't use these things. We need to meet certain requirements on that, exactly how much water we need to use, what the consistency has to come up as. And then eventually they expect that it meets some performance, such as strength, shrinkage, durability, etc. And that has worked for a while because it has some history to it. And the problem with that history is that people are not willing to uh, move away from it. I think nowadays we have the opportunity and the knowledge within the concrete industry who understand all their materials so that they can optimize it so that they can develop a product that is specifically catered to the application that it's going to be used in. Okay. And we have a wide range of applications from foundations and buildings, from exterior slabs, interior slabs that have to be polished, columns that need to be high strength, and up to big, massive structures like dams, etc. And all of the concrete mixtures for these applications have to be different. They have different performance requirements. So as that as background, I want to say that a prescriptive specification is when the buyer tells us exactly, or not exactly, but generally has some constraints on how we put that mix together. That's looking at the concrete materials. A performance specs on the other side is when the purchaser or the buyer tells us how he wants this concrete to perform in its freshly mixed state, and ultimately when it's hardened in the structure. So in that case, they have to define certain properties that have to be measurable by some standard test methods. Okay, so that's essentially the difference between a prescriptive and a performance spec. That's looking at the concrete materials as itself. When you look at a construction specification, it gets a little broader where the designer also tells the contractor how exactly they need to do something rather than what needs to be achieved in the final structure. So that's essentially what I think is the difference. Now, you have a prescriptive versus a performance specification. The responsibility changes a little bit, okay? If someone tells me how to make the cake and they don't necessarily like the taste, well, that's too bad. You told me how to make it, right? And that's how it ended up. On the other side, when they want you to meet a certain performance, then the responsibility shifts to the concrete producer because now they have to put that mix together to meet those expectations. The other side of this is the business side, right? How much do we over-design our mixes for different applications, right? If we want 3,000 PSI concrete, do we actually supply 5,000 PSI concrete unnecessarily? And that is true with a prescription spec, okay? If we had the responsibility and the authority to optimize our mix for a certain performance, we probably can do it better and hopefully also be more profitable in that game. Yeah.
Yeah, it seemed I was reading one yesterday, specification yesterday on a project that we're about to turn in a proposal on, and it seems like the most, and I see this a lot, and I guess I got kind of immune to it, but it seems like the specs are kind of a mix of both. Um, there's a maximum or a minimum, say, of fly ash or slag or some other uh, material that they want you to stay in bounds with, and then you always have the table of the mixed designs that they want you to meet. So they're saying, hey, you need a 3,000 with this slump. You have a 4,000 with this slump, or a 5,000 with this slump. Is that, what would you
Yes.
consider that?
Yeah, so that was what we call a hybrid spec, because what happens is we started off with a prescriptive specification. There was a desire to move to performance, and so they added some performance requirements, but sort of reluctant to remove some of the prescriptive requirements that historically have been there in the specification. So now you might get contradictions between what you need to achieve and what you have to use. So those tend to be also problems.
Yeah, and then when you have to submit these mixed designs to the design team, the engineer, for their review, and more we're seeing, back when I started, there was a rejection stamp or there was an approval stamp, and now we're seeing just a reviewed, which seems like they're kind of not taking any responsibility for the mixed design at all. And I think they're mainly just looking to make sure that if they said, hey, you can only use this much slag or this much fly ash, that you're within those bounds is what they're looking at. And maybe they look at something else in there. I don't know exactly what they're looking at, to be honest. But and then they hit that
That
reviewed stamp, and then it's then it falls on to the ready mix supplier. Again, I guess to meet this hybrid spec, and also and obviously concrete contractor. So it's
true.
it's a confusing world right now, Colin.
Yeah, so the concept of acceptance of a submittal probably has been interjected by the legal department of a design company. So, and so there's a reluctance to say accepted, and in those situations. Um, so we write these specifications that submittals can be of two formats. One is informational, where the designer sort of knows what's being used or whatever, and those would be the mill test reports for the thing. And then there are um, documentation that you comply with the contract documents. Technically, they should be accepted because that sort of gives a check mark to start the job. So that's but reviewed is a concept, but at least they know what's happening. And I think when they put accepted, they might be, according to the legal department, accepting a responsibility that they may not be wanting to do. That's just semantics in my mind, I think. Sure.
Right. I think I know the answer, but as someone that represents NRMCA, what is y'all's preference as far as prescriptive versus performance?
Um, so if, let's say, the concrete producer is happy with being a trucker, then they comply with the prescription and deliver the product that way. Their liability is minimal at that point. If they meet the strength or slump or whatever requirements, good. If they don't, then they can say that well, you told me what to do, and it didn't work. On the other side, they have to meet a performance requirement, they have to do some homework. They have to, and the evolution is difficult because if they haven't developed some of these mixes with the performance angle, strength is easy. Everybody develops mixtures for strength. When you talk about permeability and shrinkage and some of the other performance properties like modulus of elasticity and stuff, it can get a little more difficult to put that mix together, and achieve the requirements that way. Yeah.
Yeah. Would so how do if it's a prescriptive specification where they tell you what to put in the cake mix, as you used that analogy,
Yeah.
how is it determined that you actually followed that prescriptive spec beyond the submittal that you gave them at the beginning of the job? So if you're in the middle of a job and there's a problem, doesn't meet strength, there's a shrinkage issue or whatever, how is it determined that the ready-mix supplier actually followed that prescriptive specification?
Well, I don't think that's different whether it's a prescriptive or a performance specification, because when you are required to develop a performance specification, you come up with all this data that is needed and you develop a proposed mix. What happens during the project, of course, can be documented in terms of batch records, that you know that these materials were in the bins and silos. You have a accurate documentation of how much was batched. But we also have other issues such as maybe the sand moisture wasn't correctly measured. Maybe the truck wasn't emptied before it was batched. And at the job site, we don't know what happens when someone requested things. So in general, most of the quantities that we have used in the concrete can be accurately documented, except for the water. Water tends to be our biggest problem, correct? Because it can come from so many sources, and that affects the quality of the concrete in general, correct?
Yeah, I'm trying to think that in a prescriptive spec, if I've ever seen someone say you can only use so much water.
Well, they control it by water cement ratio in general, correct? So they might tell you that you should use a minimum cement content. So let's talk about what are the typical prescriptive requirements that we see, and you mentioned some of them. First of all, the more common one is a minimum cement content or cementitious materials content, right? Now, there are no such limitation in any of the ACI standards regarding the minimum cement you have to use in the mix, but these are there in the specifications used on projects. The other limits as we go to sustainability, some of them now put a maximum quantity on the cement, right? Because cement contributes to your carbon footprint, and so they don't want you to use too much of that. That may be a problem with achieving early strength or later age strength, whatever. Okay. Then there are limitations on the type and the quantity of fly ash or slag that you can use. That's probably the biggest prescriptive type limitation that we see. Then there could be things like water cement ratio that are extremely conservative, that either push up the cement content or push up the strength way more than you need, right? And then there are prescriptive requirements on the gradation of the aggregate, for example. And that sort of controls, maybe the intent is to control the shrinkage or something like that. So there are those types of prescriptive requirements, whereas you can probably measure the intended property better than trying to control how that mix comes together.
Right. I was, I guess what I was getting at is that the testing of the concrete doesn't change at all. It, if you have a prescriptive spec versus a performance spec, there's nothing different as far as concrete testing at all.
It does. So let's look at a prescriptive spec and evolution to performance. Okay. We don't have to get very exotic with 95% of the concretes that we place. Okay. And so the main intent is to remove prescriptive requirements that impact our ability to achieve the intended performance. Okay. That restrict our ability to optimize the mixes, both for performance, sustainability, and cost, right? And then if you need a particular performance beyond strength, specify that. For the most part, these would be done during the mixture development phase as a pre-qualification test, because many of these tests are not very conducive to job site sampling and testing. Okay. Now, the most common things that we test on concrete when it's delivered to the concrete, does it have the right air? Does it have adequate slump? Is it of the right temperature? Okay. And very rarely do we measure the density, which would be a very good property to measure, because if we got a wrong density, we know there's something wrong with the mix. And then we make cylinders and we subject them to the whims of nature that impact its property. And we get an indication 28 days later that we may or may not have met whatever the designer wanted for that in the structure. Okay. And that's probably the biggest complaint people see, is that everybody screws up our test specimens and we don't get a proper indication of our strength when that is measured. Okay. So if we can't measure strength, which we've been supposedly doing for 100 years, then throwing out some of the other more exotic performance tests to job site testing is a big problem. Okay. Yeah. So that's one of the concerns. So you can develop a mix. You can evaluate that mix either in a lab or in a small production setting and measure its permeability, measure its shrinkage potential, measure its modulus of elasticity. Those sorts of things you can measure. And once that mix has been approved, that it meets those requirements and it can be placed and constructed properly, then you have a mix that is supposedly going to work for you. Okay. The other problem once you make a submittal is there's an expectation that you stick to that submitted mix, which doesn't really make sense because it gets cold in the morning and it gets warms up in the summer and you have to make some adjustments. It's cold today and you get another warm spell. Things have to change a little, you know. So those adjustments are sort of the responsibility of the producer. He's got a responsibility, first of all, to batch the concrete accurately, anticipate the delivery time, anticipate when the contractor is ready to receive discharge, and then how he places that concrete can impact the properties. Whether he pumps it, places it in a bucket. So it's sort of amazing that we get it right most of the time, considering all these factors that have to be predicted in that sense. The problem that I see is that, let's say that we have an estimate that the materials cost about 55% of the sale price of concrete. Naturally, the most expensive of that is the cement, right? There is a cost for delivery. There is a cost for just equipment, everything else, front office costs. So when someone establishes their cost for concrete, they have to consider all these factors. And if you can optimize 55% on your materials costs and get a better performance, that would be the ideal situation for a concrete producer to work with, because then they contribute to the profitability of the company.
Yeah. You mentioned it would be nice if well, I don't know if you said nice, but it would be good if we were able to test the density of concrete. What would you mean by that? How would you do that?
Well, the density is part of essentially you put it in a bucket and you weigh it and you find out the density, right? So when you make up a mix design, you measure the density, you determine from that density what that approximate yield of that batch should be, right? And so let's say I've designed a mix and it should be about 145 pounds per cubic foot. Okay. So when I deliver that concrete, if someone measures the density and it's at 140 pounds per cubic, it couldn't have been that light. And it's light because of maybe two factors or three factors. Either I added too much water, or I have too much air, or I substitute the cement with something else. That's what makes it lighter. We also say that we sell concrete based on volume. And the only way to determine the volume of concrete in a truck mixer is to measure its density. Okay. Then if you know how much material you batched and you divide that by the density, you know the volume of concrete in a truck mixer. But the test labs will not measure density. So you don't get a initial or early indication that there is something wrong with the mix. Okay. Because it's sort of a signature of the mix. And it's an early signature, Slump is crap because it's useless. We should have thrown that tester along the way, But if the contractor wants something that flows well and we add too much water to it, then the density will tell you that something was wrong with the mix.
Yeah. Why don't third-party testers like doing the unit weight test?
They will only measure it for lightweight concrete because of the specification requirement for lightweight concrete. There is no specification for for normal weight concrete. So therefore they say if there's no spec, then why be measuring it? That's their argument. The main thing is they probably don't want to bring a scale to the job site to measure that. Mostly you're filling up a pot to measure air content. All you have to do is put that pot on a scale and you got the density. So it's not a hard thing to do, but it's the logistics that people don't want to do.
But it sounds like it would be beneficial, right?
It would be. It's a good additional information to have, both that you're yielding the mix right and that you have no problems with how you batch that mix.
Yeah. Could you not figure out, we're already making cylinders, can you figure out what a cylinder should weigh and just weigh the cylinder? And that's yeah.
You can weigh the cylinder before you test it. But a test lab that's breaking 200 cylinders a day, that's going to add another 5 minutes to their jobs. They don't want to do it.
Well, they bill by the hour anyways.
I don't know about that. They probably bill by $10 a cylinder or something. And yeah, so they're not going to get that money.
I've only experienced a couple times where the GC put the testing underneath our contract as a concrete contractor. I think I've only had it happen to us once or twice. It's I see why they did it to us, because it's hard to project how much testing they're going to use. So it's
right. So the other thing that we have, and this is the biggest complaint in the industry, that the testing is pretty atrocious, just for strength. And so there are several initiatives. NRMCA recently put out a position statement that we need to ensure that testing is done right. There are several reasons for that. First, we need to know that the concrete going in our structures will be safe, right? Secondly, we need to know that uh, we don't pad our concretes to avoid the problem of bad testing. Okay? That's a big cost item. And in this world of sustainability, we add a 20% higher strength just to avoid the problem of bad testing. So that's a approximately 20% increase in our carbon footprint, just because of how we pad our mixes for that purpose. Yeah.
Yeah, I got my copy of the new code.
ACIC 23.
Yeah, I was getting to the front of ACI. Yeah, ACI 323.
Yeah.
Low carbon concrete code requirements and commentary. I gotta read through it. We're gonna do an episode on that one once I finish reading it. But but I brought that up because I think there's something in there about ignoring the overdesign or something like that.
I'm not sure it's ignoring the overdesign. I think when someone says that I want 3,000 psi concrete, okay, that's the way we then quantify that 3,000 psi concrete has so much of a carbon footprint, okay? And so we have quantified in different regions what the industry average carbon footprint for a 3,000 psi mix is. What the low concrete carbon is trying to do is trying to encourage maybe the producers to get lower than that average. Okay, so that's the intent. While if we didn't have ACI doing this, then we would be out there with, to everybody's whims, saying, well, I want something that is zero carbon, which is not achievable. So at least we have a way to define this and a way to quantify that we're achieving this. So it's new to the industry. Some regions are progressed a little further than others. But now that the federal government has got into the sustainability realm, we think that most of the producers will start developing these environmental product declarations that establish what their carbon footprint as one of the impacts are.
Mm-hmm.
Now, the other thing that I can say is that with the focus on the carbon footprint, it goes hand in hand with performance. Okay. So if someone wants a low carbon footprint, then they need to remove their prescriptive requirements in the specifications. Otherwise, it makes it much more difficult to achieve that low carbon. Okay. So the minimum cement contents have to go away. Maximum limits on supplementary cementing materials have to go away because those constrain the carbon footprint. So you can have two producers that develop a 3,000 psi mix, and one pays a lot of attention to how he puts that cake together. He can get a carbon footprint that's much lower than the other producer. Yeah. And the main goal there is to minimize the volume of paste in the concrete mixture, because the volume of paste is what governs the carbon footprint. When you reduce the paste volume, you will reduce its permeability, therefore improve its durability. You will reduce shrinkage, therefore its reduction in cracking potential. You will increase its modulus of elasticity. Okay, so it sort of goes hand in hand. Whereas if you only had strength, then you keep shooting for as high as you can to protect yourself, which increases the carbon footprint and increases the cost. So there are some synergies that you can look at as you work with performance and sustainability.
Mm-hmm. So you're saying if folks adopt this new code, the 323, that it's leaning more towards performance versus prescriptive?
Well, the 323 is solely targeted on reducing carbon footprint. Okay. The next step has to be to guide the designer to modify their specifications to support that, and then to define only the performance that they need for that application. We don't need to measure permeability on all concrete. We don't need to put a maximum risk ratio on all concrete. We don't need to measure the shrinkage on all concrete. It's application specific, depending on what that concrete is going to be exposed to and the loads it's going to see. Right.
Mm-hmm.
And it's a difficult process, yeah, because we've been talking about evolving to performance. There is reluctance from the designers. There is reluctance from the concrete producers. There's also reluctance from the contractors. Okay. And the concept of the next step of performance was if I did all my homework and optimize my mix design, then why should I tell you what that recipe is? No, that's a big issue, right? Because now you're trying to say, okay, this is confidential information. And I can tell you in a submittal the properties that I measure on that, but I won't tell you what it's composed of. And a lot of people are not happy with that part.
Yeah. I don't know another building material that gets scrutinized on what its makeup, what's in it.
Yeah, because that's tradition. And people feel comfortable, even on the cement, right? If we know what the chemistry it is, even though we don't know anything about the chemistry, but because it had the same chemistry before, we want that same chemistry today. So there are these efforts now of naturally from the cement industry, because they are the biggest contributor to carbon dioxide, to reduce their carbon footprint. Okay. And while they reduce their carbon footprint, we can benefit in the concrete industry from that. But if it's not done right, then we have to use more cement to get the same strength. Sort of defeats that purpose, because eventually the performance and carbon footprint of concrete is what needs to be achieved, right?
Mm-hmm. And we're going to end up using more concrete anyways to fix.
We'd like to use more concrete. That's right. Yeah. That's one of the challenges of the sustainability. Do we push the envelope for low carbon without consideration on the effect on the performances? Okay. Do our slabs finish differently? Do our formwork, does it take longer to cycle our formwork? Does it take longer post tension our structures or to tilt up a wall? How will that affect schedule? So naturally, contractors are about some of that. They have to get used to maybe a low carbon world. Things might be slightly different, and they have to change in those things. Yeah.
Hmm. Remains to be seen, Colin, I think.
True,
Well,
that's true.
well, I think this is a good spot for us to end today, Colin. If folks want to reach out to you and learn a little bit more for you, I know you speak at ACI conferences all the time, right? And
Yeah, I don't speak that much at ACI. Only if requested, I will speak. But I do get involved in many of the NRMCA education courses. Our concrete technologist course is offered twice a year. We also just finished a durability course that's offered twice a year. We develop publications that help with guiding the industry on the right things to do. We are writing, or we have a guide to improving specification with suggested language on specifications as well as commentary or advisory information on that. We, sit on the various ACI and ASTM standards committees, trying to slowly make the evolution to performance.
Mhm.
Yeah.
Yeah. Well, that's great. I will. I'll give folks your email if that's okay.
That's right.
Yep. I'll give you.
And I'll make one plea that the standards impact everybody, and we need the industry to participate on these standards committees because everybody just has one vote, and we need a lot of the expertise to make our standards more realistic and less academic.
Yeah, I agree with that, and that's what I'm hoping the podcast will do is get more folks to talk about these things because otherwise we're going to just be handed something that maybe we don't want. So we gotta speak up.
Well, thank you, Seth. I appreciate you having me over, and I wish you and your crowd a happy Thanksgiving.
Oh, thank you. And yeah, until next time, folks, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for a dollar, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done.